Hello everyone, I am Dr. Arindita Shah from W Department of Regional Education and Research Foundation Group of Institution. So today I will discuss the MAKAUT question paper solution of the year 2024-2025 on the subject electric drives PCEE 701. So let us begin. So here today we will discuss the very short answer type question, that is the group A. Here you will be having 12 questions, means in the year 2024 there were 12 questions in group A, out of which they had to answer any 10 of their choice. So first question was, why heating occurs in motor drives? First short question is, very short question is, why heating occurs in motor drives? So you have to answer in a single line, that is, heating occurs due to copper losses, coal losses and mechanical losses. So we can see that in case of motor drives, the heating is occurring due to three types of losses. One is copper loss, next is coal loss, and the third is the mechanical loss. Now what is the explanation behind it? So what happens, you have the motor windings. So when current will flow through those windings, then what will happen? The conductors are present in the windings. So electric resistance present in the conductors, that will produce heat, and that is called as the copper loss. This will lead to copper loss. In addition to this copper loss, the magnetic core also suffers from hysteresis loss. And how this hysteresis loss occurs? It is caused due to repeated magnetization and demagnetization. Along with that, eddy current loss is also occurring, which occurs in the core due to circulating currents. So all these losses collectively are known as the core losses. That is, the eddy current loss and the hysteresis loss, both combined is called the core loss. So till now we have seen two losses, one is copper loss and the core loss. The third part, in the machine there are few moving parts like bearings and fans. All this will cause mechanical losses due to the friction and air resistance. So all of this together, means all these three type of losses together, they will produce heating in the motor drive, and if it is not controlled, then ultimately it will lead to the damage of insulation and lessen the efficiency of the motor drive. So heating occurs due to copper losses, core losses and the mechanical losses. Okay. So next question is, which type of drive is used in electric vehicles? In case of electric vehicles, we go for either BLDC or induction motor drives. BLDC is brushless DC motor. In case of electric vehicles, the motors which we have to use, they should be very their weight should be light, that is, they should be lightweighted, efficiency should be high, and also they should be able to provide high torque over a wide speed range. So when we have to design the motors for electric vehicles, we have to keep it in mind that the motors that we will be using should be of lightweight, they should be efficient, and more over that, it can provide high torque over a wide range of speed. So brushless DC motors, that is the BLDC motors, are mostly used in smaller electric vehicles and two-wheelers mainly. They will have high efficiency, low maintenance and good speed control. In case of high performance electric vehicles such as Tesla cars, in those cases we use induction motors. Why we go for induction motors in case of high performance EVs? Because they are rugged, they can handle overloads very well and have excellent level of reliability. So both, whether it is a BLDC motor or it is an induction motor, both are controlled by sophisticated power electronic drives. The next question is, which control mechanism is used to get speed higher than the base speed of a DC shunt motor? Which control mechanism is used to get speed higher than the base speed of a DC shunt motor? The answer is field control. Why field control? In case of DC shunt motor, the speed is inversely proportional to its field flux. So if the field current is reduced, then we can weaken the flux. So if the flux gets weakened, then it will increase the speed beyond the rated or the base speed, at the same time keeping armature voltage constant. That means we know in case of a DC shunt motor, speed is inversely proportional to field flux. So when armature voltage is kept constant, at that time if the field current is reduced, the flux will be weakened and this will increase the speed beyond the rated or the base speed. So this concept is called the field weakening. However, torque decreases at higher speed. So this method is used only for high torque, where only when high torque is not required. So for lower torque we can use it. The next question is, what is meant by VSCF drive? That is variable speed constant frequency drive. Variable speed constant frequency drive. In a VSCF drive, what happens? The mechanical speed of the prime mover, it can vary. That is, it is variable in nature. But at the same time, the electrical output frequency remains constant. So there is a one constant term and another is a variable term. Mechanical speed of the prime mover may vary. It can vary. Whereas at the same time, frequency of electrical output, that will be constant. So it finds an application where in aircraft power systems where speed changes with flight conditions. Still, the onboard electronics, it requires a fixed frequency. At the same, also it can be used in wind energy systems, which will allow variable rotor speed operation, at the same time providing stable frequency onto the power grid. The fifth question is, what is the expression for step angle? The step angle is equal to 360 degree divided by number of steps per revolution. 360 degree divided by number of steps per revolution. So in case of a stepper motor, it moves in discrete angular step. Now this step angle, what does it indicate? It will tell us how the shaft rotates with each control pulse. Suppose if we take a motor which takes 200 steps for one full revolution. So in that case, each step will move the shaft by 360 degree divided by 200, that is 1.8 degree. The more smaller the angle, higher is the positioning precision. Next question is, how will you classify the electric drives based on the method of speed control? So they are asking about the classification of the electric drives on the basis of method of speed control. So first is constant torque drives, next constant power drives and variable torque drives. In case of constant torque drives, what will happen? The torque will stay same where the speed changes. Means in the name itself we can see that it is a constant torque drive. That means anyhow your torque will be constant, but speed changes. So this concept we will find in conveyors and compressors. In case of constant power drives, um, power is the product of speed and torque. So this will be constant and it is found in machine tools. Variable torque drives have torque which is proportional to the square of speed. So if torque is T, it is proportional to, suppose speed we denote by capital N, its square. So torque is proportional to square of speed, which is found in pumps, fans, and this classification, that is constant torque drives, constant power drives, variable torque drives, all these are classified on the basis of how the load behaves with speed changes. When speed is changing, how the load behaves with respect to that. The next question is a three-phase induction motor drive having a combination of a diode rectifier and line commutated inverter in the rotor circuit can give speed dash synchronous speed. So it is a fill in the blanks. So our answer can be will be both below and above synchronous speed. So you are having a three-phase induction motor which is a combination of a diode rectifier as well as a line commutated inverter in the rotor circuit. So how much speed they can give? It is the below and above synchronous speed. So this arrangement, this type of combination, it is a part of slip power recovery system. So in that case, the slip power which is received from the rotor, it is converted to DC by the help of a diode rectifier. Then again it is fed back to the AC supply through a line commutated inverter. So by controlling the inverter, we can make the motor run either below or and above the synchronous speed efficiently. So whether if the synchronous speed is capital N S, then this less than it and more than it can be used. Next is what is meant by short time rating of a motor. So short time rating of a motor. So in the name itself it says that short time means short duration. So this is the maximum load a motor can handle for a short duration without causing any overheating. Sometimes it is seen that the motors are required to operate for small periods, that is brief intervals, at higher than the rated loads, such as cranes, in case of cranes. So in these cases what happens, if short time rating, if it can be defined in these cases, is like how long, means for how long time the motor will run before its temperature rises to a maximum safe limit. So, and cooling time after this operation is essential to prevent insulation damage. The next question is for the speed lower than the base speed of a DC shunt motor. This is armature voltage control is used. So if in the range which is below the base speed, we can control the motor speed by reducing the voltage applied to the method. So in this method, the flux remains constant, so torque capability remains high. It is simple, it is effective, and it will provide smooth speed variation for loads requiring high torque at low speed. Next question, the direction of MMF when a single phase supply is given to the stator of a three-phase induction motor. It will produce a pulsating magnetic field. A three-phase stator, it will normally produce a rotating magnetic field, but when only a single phase supply is applied, the magnetic field does not rotate. What will happen? It will instead of rotating, it will pulsate back and forth. front and backward in the same direction. This pulsating field, it cannot start the motor on its own. Therefore, what will happen? You need an auxiliary winding or a starting method is needed. Next question is, the variable frequency control of an induction motor is more efficient than stator voltage control. Is a statement and you need to explain why. Because it maintains constant flux and reduces losses. So in case of voltage by frequency control, V by F control, both voltage and frequency both can be changed in proportion in order to keep the air gap flux constant. If air gap flux is constant, is maintained, then it will minimize the core saturation and iron losses. Whereas in contrary to it, if stator voltage control only it only changes the flux, it will lead to higher losses and poorer torque control. So that's why V-wave control method is preferred for speed variation. Next question. Why is it necessary to operate a solar panel near the maximum power point? Why is it necessary to operate solar panel near the maximum power point? In order to extract maximum power and improve efficiency. So, in case of solar panel, VI characteristics, it has a single point where the product of voltage and current, that is power, is maximum. So that point is called the maximum power point. Now we have to operate in such a way that we make use of the maximum available sunlight, unless it is a some calamities or climate condition is there. So how much ever is the sunlight, we have to use maximum part of it. So for that, MPPT, that is maximum power point tracking controllers, they automatically adjust the load in order to keep the panel working at this point. So we have to operate the solar panel near the maximum power point in order to extract the maximum power and improve the efficiency. Thank you. This was all about the Group A solution, question answer solution. Thank you so much.